Hi, this is example number 2 of section 16.3. So we have two gears, gear A and gear B, both rotating about fixed points in A and B, and they meshed in, let's call this point P, they mesh in point P. We are given that gear A has an angular acceleration of alpha A equals 40 cubed radians over second square and an initial angular velocity of 20 radians per second. So when we are being asked to find the angular velocity and angular displacement of gear B. So given data from gear A, we want to find data from gear B. So the first things we have to know when we are talking about gears is that there is rolling without slipping between those 2 points. So the velocity of these 2 points, let's call this P and this P prime, the velocity of P prime is equals to the velocity of P. And actually, we have to say too that the tangential acceleration of P prime is equals to the tangential acceleration of P. Very important to remember that since this point P prime and this point P, if you see this is a curved path that this point has, it has also normal acceleration. So if we call that acceleration of Pn, that will be the normal acceleration, and that normal acceleration will be equals to omega of angular velocity squared times the radius of P, and that will be totally different from that acceleration, because that acceleration in the normal direction will be square of angular velocity of, so let me write it right here, Pn will be angular velocity of A square r, radius of A, r, and this is angular velocity of B. So those two accelerations, we cannot relate them. We are able to relate the tangential acceleration, and the tangent acceleration in this case will be the angular acceleration of A times RA, and that will be tangent acceleration of B, RB, and those are equal. Since we are asked to find angular velocity and we are given angular acceleration, so we want to find the angular velocity of A to be able to relate it with B. Those expressions are equals for angular velocity and are also equals for angular displacement. So if we are able to find angular velocity and angular displacement for gear A, we will be able to find the angular velocity, angular displacement for gear B. So the first step that we will do for the solution of this example is find angular velocity of gear A. The angular acceleration is equals to the derivative of the angular velocity. So then the angular velocity will be the alpha times differential of time, and I can integrate both sides of the equation. T1. So from here we can say that if we integrate this part of the equation, we get that the angular velocity for a specific time minus the initial angular velocity. We are doing that for A, so let me write that A here, will be equals to the integral from 0 to time. Let's do it, I know I will substitute 2 at the end, but at this point I'm going to integrate that as a generic, so that will be. So finally we can say that the velocity of A will be equals to the velocity of A initial plus 4 times t to the 4th over 4th, right? Evaluated in 0 and t, generic. So finally, and this is 20 because it's given, so we have that the velocity of A will be 20 plus t to the 4th radians over second. Okay, so that is my expression for angular velocity A. I want to find now the displacement I know that the angular velocity is the derivative of the displacement, so I do exactly the same. And so the displacement will be equals to the integral between 0 and t of this expression right here, 20 plus t to the 4th d dt. So that will give me that my displacement of A will be equals to the displacement, the initial displacement plus 20t plus t to the 5th over 5, and all that will be in radians. So that will be my expression for the displacement. I found the angular velocity and the angular displacement of A. Now we can substitute for that time. For t equals 2 seconds, I get that the angular velocity, I have the value right here, is 36 radians per second. And what I did only was plug 2 over here. And the angular displacement is equals to 46.4 radians. So I just plugged 2 seconds in these two equations and I got the values for that specific time. But we are not being asked to find the angular velocity and angular displacement for A, but for B, then we have to use these relations, which are very straightforward. So using relations for point P, we know that the angular velocity of B will be equals to the angular velocity of A times the radius of A over radius of B. So that will be equals to 36 times the radius of A is equals 0.05 and the radius of B is equals 0.15. And that gives me a velocity of, for B, equals 12 radians per second. And I do exactly the same for the angle. And I get that the angle of displacement, the angular displacement of B is equals to 15.5 radians. And those are the results that we were looking for. I think it's not given. This is 0. So just to know that when you plug 2 here, you will get that value. And those are the values for B. If we wanted to find the acceleration, it will be the same relation. So you want to see also the solution in the PowerPoint presentation? There it is.